Good morning. You can do better, team. Good morning. That's much better. You guys having a good Ignite so far? Awesome. All right, so we're here talking about big data. In particular, we're going to take a survey of the entire big data landscape at Microsoft. And we're going to understand how these products have actually come into existence and what is the purpose of them being there on the Microsoft portfolio. Now, just to set the stage here, in 75 minutes, I don't think I can humanely go any deeper than an overview level of the entire landscape. So this talk will certainly remain at level 200 from a technical level standpoint. But then the interesting thing is, this is your foundation for the rest of the week as you dive deeper into a lot of these products and services. And I'll try and call out some of the sessions that are going on throughout the week on various topics as well. Now, on the topic, we're here understanding big data on Azure, and we're going to talk about structured data and unstructured data, and even data on the fly that's streaming data. To introduce myself, I'm Nishant Thakur. I'm a technical product manager for the big data set of services at Microsoft. I look after the entire portfolio for big data and analytics. So anything from data ingestion to storage to compute engines, scale out, and then doing analytics, including advanced analytics on top of it, falls under my purview. Now, as we get into the session, I really wanted to take a moment to try and understand this audience as well better. So let's do a couple of questions here. The first one, how many of us have actually worked, and I mean worked, on big data at some capacity over the last year or so? Very nice. Now my second question, how many of us have played around with some of the Azure services for big data? Pretty much the same audience. That's pretty good to know. But that's about 30% of all of you over here. So I'm going to go and give all of you a view of the entire landscape, and then we'll take it from there. Feel free to ask questions, but I'm informed this session is being live streamed, so I'd request you to walk up to one of the microphones so that people on the live stream can hear your questions as well. Don't bottleneck the session on a particular personal or your organizational challenge, which is very typical to yourself. It's a wide audience, so we should just keep it at that, all right? Now, let's take a quick moment again to identify what are we talking about. We're talking about big data. What is big data? So I actually want to take this slide to define how I think about big data and what I will be talking about from a big data perspective. So from my perspective, big data is a term for data sets that are so large or complex. The complex piece over there is important, ladies and gentlemen. Pay attention to that piece as we go into some of the challenges that come in as well. And it's so large and complex that traditional data processing application software is inadequate to deal with it. Now, the challenges that come with it are manifold. The complexity that comes with it is manifold. Certainly, it is the volume. So your traditional systems are not equipped to handle that kind of volume. But more importantly, it is the variety, it is the velocity, it is the tenacity of that data, and it is the complexity of the analytics that you want to perform on it that sets big data apart from the rest of the traditional data ecosystem. Now, it's interesting to understand that these two environments don't exist in silos. They actually are intended to coexist together and to complement each other. Okay? Now, the next slide may be a slightly overwhelming one, but let's get to it and piece it together as we go along. Now, I could just go ahead and throw up the slide and say, here's the Azure data landscape. We deal with small data, big data, all data over here. And I could just walk off the stage and let you guys decipher the slide for yourselves. But then I do have 70 more minutes to kill, right, in the session. So I will certainly go ahead and talk about a few, if not all of these technologies. So let's start with the left-hand top corner. The first problem that we have is data ingestion. Now, whether you talk about small data or big data, ingesting data into the cloud or into any system whatsoever is certainly the first problem that you encounter. Now, how do you go manage that? On Azure, you have a set of capabilities that can allow you to manage this ingestion of data. As we get along, the first service that I'm going to talk about is Azure Data Factory. Now, Data Factory is not just an ingestion service. It's actually a scheduling, orchestration, and ingestion service, which allows you to create sophisticated data pipelines right from ingestion of the data through to processing, through to storing the data, and then making it available for your end users or business systems to tap into. Now, all of us should remember that when I say it's a data orchestration engine, it means that it does not have any compute power of its own. It is literally tapping into some of the other services on the Azure environment to go ahead and deliver that compute requirement that you may have. Okay? Now, we'll dig into this a little more when it gets to it. But the second service that I want to talk about, and it's especially useful for incremental data as you get, once you've gone ahead and loaded up some amount of data on Azure, and now you're incrementally getting more and more data by the day, by the hour, you want to go ahead and leverage a service that can bring that data on Azure as well. Now, that's the Azure import-export service. In essence, you can also go ahead and leverage it to bulk load a lot of data into Azure. It essentially means that if you have terabytes, if not hundreds of terabytes of data, and you want to put it up on the public cloud, you cannot just put it on your bandwidth and rest that it'll get completed on a particular day. You need some dedicated environment to make sure that happens. And import-export service actually provides you with that ability. Now, in addition to that, you've got the command line interfaces and the SDKs as well. The Azure command line interface is designed for all of these bulk uploads to happen in parallel so that you don't have to wait until eternity to get your data on the cloud to do your analysis upon. And then, of course, the SDKs that you can plug into your applications generating that data in a way such that the data at its source is getting generated in the cloud itself, rather than getting generated somewhere else and getting transported to the cloud. Okay? Now, the second set of services that I want to talk about is the operational database services. Now, this is the Azure SQL database and the newly announced Azure Cosmos database services. Now, the SQL database offers a SQL dialect. It offers a database for MySQL. It offers a database for PostgreSQL as well. So you've got our Azure databases for all the three dialects that you need from that perspective. The more interesting piece, though, over here is Cosmos DB. Cosmos DB happens to be that awesomeness from the NoSQL standpoint, as well as from some of the other data processing standpoints and storage standpoints, such as Graph and Mongo and HBase, and bringing together document APIs, etc., to allow you the flexibility of bringing in data in its native form and leveraging it for your applications to tap into as an operational environment. Now, Cosmos DB is also interesting from its nature of being completely globally distributed and having multiple consistency levels for the kind of applications that you're creating. What is also very interesting is it has plugs into the rest of the Azure ecosystem to allow it to become much more than just that operational database. So it has plugs into Spark, for example. It has plugs into Azure Functions for you to do some change data feed and do some Spark-enabled computations on top of data stored in Cosmos DB. Now, if you're in the operational database space and you want to go ahead and do reporting and dashboarding upon it, well, you're going to go ahead and create an analytical data warehouse first so that you can combine all of this data from various data sources and bring it all together. But what happens when your data doesn't really have that structure? It's not conformed to the rectangle of rows and columns. That's when you need a specialized big data store that can cater to your analytical requirements and cater to the size and unstructured or structuring when reading the data behaviors of your applications and analytics environments. That's what Azure Data Lake Store and the Azure Blob Storage provides you on Azure. Now, both of them have a place, and we'll talk about what that is and how that kind of sits together. But when you get that data into such a big data store, now you need some specialized compute engines because your data is complex. It is high in volume. It is very high in the kind of complexity of analytics processing that you want to perform. And you want to scale it out because you don't want to wait for days, if not months, to get results from your data analysis. And that's where you have these specialized compute engines like the Azure Data Lake Analytics with its awesome uSQL language and the goodness of open source analytics offered as a managed service on Azure with HD Insight. Now you can go do the craziness of all the animals in the zoo with Hive and Pig and Oozy and Spark and whatever you can think of from the open source perspective and tap into this data lake of yours and do some analysis on top of it. But then it becomes a little more interesting. This is all good for data that's coming in batches. How about streaming? I'm getting real-time data. I need insights in absolute real time. How do I go about getting that? The first problem to that is, how do you ingest that data in real time? Is there a system that can allow you to go ahead and tap into that data as it is getting generated and make it available for you to analyze in the form that you need it, and then be able to deliver the insights back to your users? Well, that's the stream ingestion problem. And that's where services like Event Hubs and IoT Hub and even Kafka on the HD Insight clusters actually sit. They allow you to tap into all of those event generators and capture those events as they are getting generated and buffer them up for you, for your processing engines to really call into and go ahead and allow processing from there. Now, once you have that, you need specialized engines to process that data on the fly as well. Things that can do windowing operations, things that can do time series calculations, etc. That's where these stream processing engines really shine out again. You've got the likes of Azure Stream Analytics, and you've got the likes of Apache Storm and Spark streaming on the HD Insight clusters. That's the managed service that I was talking about. You can tap into ease of use, or you can tap into extensibility and open source friendliness with the choice that you have over here. But all of this is great. What do you do with it? Like, you've done that analysis. Now, what do? You've cleansed, you've curated that data, you understand that data, but now you want some insights from that data. The first level of insights that you get is reporting and modeling. That's the business intelligence piece. And that's perfect. We've been doing that for the last almost 10, if not 20 years. But now, more and more, we are delving into the realm of advanced analytics with machine learning and deep learning. And we are tapping into these data sets to derive even deeper insights from them to allow us to predict, if not prescribe, what our systems should be doing. And that's the like of Azure Machine Learning and the ML server on Azure. Now, beyond that, you also want to delve into the realm of deep learning. And to make that process easier, we've offered you toolkits to go ahead and create those deep learning models. But in addition to that, we've also created first-level services on top of those toolkits in the form of cognitive services and bot services as they light up. Now, additionally, when you have such a comprehensive data estate to deal with, you also need some services that can allow you to go ahead and keep a track of all of these things and literally tap into the one that you want with easy querying capabilities. That's where the likes of Azure Data Catalog and Azure Search really come in. But then, to implement such a solution, you need a platform with some enterprise-level capabilities to allow you to sit in and design those solutions the best way possible in the most compliant manner. And that's where the Azure platform capabilities come really shining up. The likes of ExpressRoute to allow you to create a private connection between your environments and the Azure cloud. The likes of Azure Active Directory, which allow you to carry forward your identity mechanisms to the cloud and tap into that with all of your underlying data assets. The likes of network security groups, where you can actually go ahead and define deeper level security principles that your networks get conformed towards. And then the likes of key management services to allow you to restrict access to this data even to Microsoft and to everybody else on it from a public cloud perspective. And then when you have these systems, you also want some monitoring capabilities to be coming in. That's where the likes of Operations Management Suite comes in, allowing you to tap into these services and look into the logs generated by the execution of these services, and then give you that insight into the health of your solutions. And then you have the most awesome Azure capability from a serverless perspective. Azure Functions. That can tap into literally any service on the slide and allow you to deliver serverless insights or serverless capabilities from the perspective of triggering mechanisms or triggering change feed captures from the data environment that you have. And then, mind you also need an awesome development environment. And Visual Studio happens to be that for us, which taps into each of these services, offering you that developer capability. Now, I gave you a very wide-ranging survey. Now, let's probably try and understand which of these services actually form part of the big data portfolio in particular. Now, when I talk about big data particularly, these are the darker shaded services are the ones that we usually talk about. The ingestion pieces, be it batch or streaming, the storage pieces from the big data store perspective, the compute engines, and then the stream processing engines, and then performing advanced analytics on top of this as well. But this is all great. And it's okay for us to kind of understand this at a wider perspective. But why is Microsoft doing this? Why is this in its place that it is? And how are all of these services fitting into a solution architecture of sorts? To understand that, let's take a quick step back and try and understand what is the core principle behind these. Now, as we take a step back, we understand that there are three very high-level trends that are converging to make data as much of a commodity as potentially an industrial revolution was. Now, when we talk about cloud and AI and data, we understand that this whole phenomenon of moving to the cloud is to allow us to be more agile and flexible. At the same time, giving you AI capabilities to evolve as a community as well as an ecosystem. But rightly placed at the center of it is data. And as we saw in that video as well, we are on a cusp right now where we are literally able to generate data from multiple devices, even for a single operation, such as moving from your seats to the door. To be able to analyze that data and to understand behavioral aspects from that data is going to give us a lot of insights in the future. But to be able to do that, you will need to manage and create systems of intelligence that will help you derive insights from that data. Now, to look at that systems of intelligence, let's take a quick look at the modern data estate as it sounds. In essence, there are two principles. You're going to have some data sitting on premises. You're going to have a lot of data sitting in the cloud. Now, there are very few organizations which are either or today. Let's take a quick survey. How many of you are conformed only to on-premises today? It's about 10%. How many of you are only conformed to the cloud today? About 5%. How many of you span across both on-prem and cloud? Look at that. The rest of the 85%. And that's what this slide delivers. In essence, you're going to have three types of systems that you're going to go create. The operational databases, which have traditionally been sitting behind your applications. The data warehouses, which will now combine data from these operational databases traditionally, and also combine data from your big data ecosystems. And then these data lakes, which will be your systems of intelligence, literally, where all of your native data resides, where you will be asking questions in the future that you don't even know of today. And you will be able to tap into those insights as they come in. Now, for you to be able to do that, you will need three very good capabilities. One is the ability to reason over that data anywhere. The second is the flexibility of your choice. It's not our choice. We don't go and create things out of the realm of our thinking. It is your choices. If you like open source more, open source is on Azure. If you like simplicity and flexibility and ease of use more, that's on Azure. If you like developer productivity more, investments in that area. And then, the perfect example of the next item from a security and privacy standpoint, the GDPR norms that are up right now, and everybody is kind of working towards making sure that things are really looking good from that perspective. Now, this is all great from a data estate perspective, but how does Microsoft play to this? Well, on-prem, you definitely have the SQL Server environment, which in itself takes care of the operational database and the data warehousing pieces with the best performance that has been recorded by benchmarks. But from a data lake perspective, you can tap into your Hadoop on-prem environments or Spark on-prem environments directly from SQL Server using something like Polybase. Now, when we come to the cloud, that story is much wider, as we saw in that previous slides. You have specialized capabilities for operational databases. You have an awesome MPP architected data warehouse, and there's no limit to what you can do with the data lake environments on Azure. Now, let's try and understand how that evolution of the data warehouse is going on. Because eventually, big data is actually feeding into that whole concept of enriching your data that exists. And your data warehouse is that one version of the truth that your organizations have always maintained. So in essence, you're tapping into that data, ingesting it, storing it, prepping and training it, and then modeling upon it or serving it to your business users, be it your analysts, be it your applications, or be it your end users or customers, to get some apps and insights. But in principle, there are three core solution scenarios to this whole concept of big data. The first one being that modern data warehouse. So essentially, it's modernizing your existing traditional data warehouses to now get enriched with data from a variety of sources and the complexity that comes with it. The second is to be able to do some advanced analytics or machine learning or data science or even deep learning on top of that data. And the third is to be able to cater to real-time processing. And the perfect example of that, the Internet of Things. That's what we are talking about from solutions in the foreseeable future from the big data perspective. Now let's tease apart each one of these to understand how the set of services in Azure actually sit and cater towards all of these capabilities that these systems or solutions require. Let's take a look at the first one here, which is implementing a big data and data warehousing environment in the cloud. Now, here's a traditional data warehouse. I'm sure you guys have seen one or more versions of this in your organizations or anywhere outside. You get a bunch of data, your business applications and your custom applications are tapping into individual databases. You have systems of integration to bring that data together into a data warehouse, and you apply BI and modeling on top of it to offer it to analytical dashboards and end users. That's all great. That sits like that on-prem, and that pretty much sits like that in the cloud. But the interesting thing is, now your applications, even if they are sitting on-prem, can be brought up to the cloud from a data perspective. You can still go ahead and have your applications tap into Azure SQL DB as your backend. And if you're not doing that and you still want to go ahead and move your data, you have specialized services like the data migration service to allow you to do that. SQL Server integration services, now also part of Azure Data Factory as a capability on the cloud, can allow you to tap into your multiple data assets from a structured perspective in the cloud and combine them into a data warehouse. Azure Analysis Services, natively built for the cloud, allows you to build tabular models for your BI needs. And then Power BI allows you to report and dashboard upon it. But that's great. how do you bring data directly to a data warehouse as well? You have humongous systems sitting, let's say, in your SAPs or your Oracles or your mainframes or potentially your SQL servers, and you want to tap into the awesomeness of scalable and flexible data warehousing capabilities in the cloud. How do you go about doing that? Well, you have the capabilities of pulling that data using any of these services. Either use the CLI, or use the data factory, or use the PCP command line utility, or potentially even SQL Server integration services. Now, this is all great. This is not something new. I'm sure all of us are aware of this. It becomes really interesting. And before we get there, let's just take a look at what the SQL Data Warehouse is all about. It's an elastic data warehouse with a lot of enterprise class features. Essentially, it's MPP architected. It can pause and resume in seconds. It can bring you all the SQL Server enterprise capabilities so that you don't have to do away with your existing information systems and the existing scripts that you have written for your data warehouses. You can bring them up to SQL Data Warehouse directly. And then it definitely taps into the rest of the system as well. Now, just to give you some more characteristics, it can scale up to a petabyte if you need it to. It can store and compute separately so that you are billed for those things separately. You don't have dependencies amongst themselves. Okay? Now, SQL database as well, I think, is interesting to understand over here, but I'm not going to go too deep into SQL database. I'm sure everybody here understands that. And then the analysis services pieces are also really, really interesting. The way you can go ahead and model and serve and then gain insights from as simple a model as a tabular model being built with the help of DAX, and you being able to tap into insights from that model. But that's all great. This is the traditional data warehouse. This actually goes ahead and breaks when your data is not all structured. What do you do then? Now you're getting log files and media files. You're bringing all of that data in. How do you go tackle that? The volume of the data is enormous. The structure of the data is unknown. The complexity of the queries that you want to write upon it is absolutely unknown to you at this point in time. But you still want to capture that data because you know there are insights that you'd like to derive from it, potentially at a later point in time, but even ask some exploratory questions of it today. That's where these big data stores really come in handy. That's where the likes of Azure Storage or the Data Lake Store is absolutely crucial for you to have here. You can now bring in data from your traditional sources via your traditional methods, but then you can also bring in data from your non-traditional or unstructured environments into your big data stores and tap into that from data warehouse via Polybase. And then the rest of your system goes on as delivered. Now you'd say this is all great, but then there's a lot of data. I mean, how do I ensure that all of this lands in the amount of time that I have, and how do I secure it? I don't trust the public internet. This is where ExpressRoute fits in. You have ExpressRoute to allow you to create a private connection between your environments and the Azure cloud so that you can take care of every bit of data that's leaving your environment and reaching the public cloud. In fact, the capabilities of ExpressRoute also allow you to define a virtual network across your environment and the cloud in tandem. That's where ExpressRoute really shines out. What is ExpressRoute? Well, of course, it's a unified connectivity to all of the Microsoft Cloud services. It's predictable performance. It's your private connection. It's your secure environment. It's your ability to tap into all of that at one go. Now, that's all great. And let's just go simplify this thing by now just talking about the big data pieces. We all understand how the traditional data works, and that's all fine. You can bring in data factory, put it into a data warehouse, model, and analyze. So just gone ahead and simplify the previous slide to now take care of only the big data pieces as they keep coming in. Now you bring in big data into storage. If it's cleansed and curated on the fly, as such that you're doing some ETL on that data before it reaches your storage, you can directly go ahead and consume it into your data warehouse. But generally, for such systems, you don't do that. It's just too huge for you to do anything on the fly. The principle for these kind of systems is not ETL. It's ELT. It's extract, load, and then transform. And that's what you're able to do from expediting that whole process with something like HD Insight. Now you bring in HD Insight, which taps into data that's sitting inside of your Azure storage environments. You're now allowing yourself the flexibility of tools like Hadoop and Spark and all the other open source analytics capabilities to go ahead and tap into that and go ahead and bring that insight or clean and curate and aggregate and process that data before it reaches your enterprise data warehouse. The process thereafter certainly remains the same. You're still modeling upon it, you're still reporting upon it. Now, what does HD Insight actually allow you to do? Well, HD Insight is now allowing you to forget if your data was structured, unstructured, semi-structured, to forget the complexity of the analytical queries that you want to write upon, to forget what kind of questions you would like to ask of it later. Because you can go ahead and do some data curation and cleansing of the data and putting it all together and adding structure to that data using some of these tools in HD Insight. Now, once you've structured that data in a form that it's consumable into your data warehouses, you can now port it via Polybase. So that barrier that your data should have structure is now taken away. That barrier that you should transform your data before it gets loaded is taken away. That barrier of you not being able to write some advanced queries is taken away. And you're able to bring all of that into the ecosystem with HD Insight. Now, this by itself is great. Like, if all of us have achieved this, probably we are way ahead of where the rest of our peers may be. But that's not all. In fact, you can actually do a lot of this using some of the other stuff as well. But first, let's take a look at what HD Insight is. It's a cloud Hadoop and Spark managed cluster service. It essentially means that we are offering you clusters of Hadoop and Spark to your flexibility at your terms with the enterprise level SLAs backed that Microsoft is known for. So even if it is an open source tool or an open source functionality that you're tapping into, we will take care of it that it functions well. If it doesn't, our phones will ring at 3 in the morning and we will wake up and make sure that it works. But the amazing thing with HD Insight is your time to analytics gets reduced many folds. And this is my personal experience. Like about 8 years back, I was tasked with potentially spinning up a 4-node cluster. It took me about 7 months to get that 4-node cluster up and running. And of course, at that point in time, the open source bits were not that mature as they are today, but still, like 7 months for a resource to get a 4-node cluster, a test cluster up and running, Today, if I have to do that, with the help of 3 clicks, within 10 to 12 minutes, I can have a cluster anywhere from 2 nodes to 2,000 nodes and even beyond if I want to. And I don't have to worry about pulling it all together and stringing it together and making HDFS work and making Hadoop work and making Hive installed on top of it, and then getting network security to work and each of those nodes talking to each other. All of that is taken care of by the service itself. But that's great. Now, you already have this concept of this modern data warehouse now, where your structured data is already getting tapped into. Your unstructured data is being brought together with the help of Hadoop and structuring it. And now you have structured and unstructured combined to report upon. Now, another option to actually go ahead and do that would be Azure Functions. Well, you can actually go ahead and, if it's a very simple manipulation of the data that you want to do, in fact, if you even want to go ahead and listen to your data lake environments and tap into it when the data comes, you can tap into Azure Functions and write your logic in Azure Functions to go ahead and manipulate the data. You can scale Azure Functions as well. But then you don't really do that kind of sophisticated analysis in Azure Functions, right? You could. Like if you have custom scripts and you want to tap into those, perfectly fine. The scalability, the complexity of analytics that gets tapped into over here is really in the realm of the HD Insight pieces. Let's take a quick survey of what Azure Functions is as well. Like it's a serverless offering, it's a compute engine. It just offers you the ability to listen and take action, and you pay for only when Azure Functions is triggered to do some activity on top of it, right? It's very, very powerful in the sense that it can allow you to code anything that you want with it. And sometimes that is really useful because a lot of our organizations don't have very sophisticated processes around data pipelining. You don't have a persona like a data engineer or a data developer. Everybody is just one developer, and they are very used to their IDEs, and they just want to leverage those IDEs to go do stuff with it. Azure Functions allows you to go ahead and make them or enable them to achieve more and do more with their time. But then, not everybody does that. Like the most common example is you would certainly have a big data compute engine sitting on top of your data lake to go ahead and process and structure and then enrich your data warehouse with unstructured process data as well. The other piece that this enables is also that now your analytical dashboards can even tap into some of these compute engines directly. If you look at that arrow coming out of HD Insight onto your analytical dashboards, just imagine your power users, your analysts who want to tap into some of the raw data to see if there is a trend that they can identify somewhere, to write some ad hoc queries and try and determine if they can do somewhat better and derive insights that can then be included in some of the reports or dashboards. That ad hoc analytics is also enabled with something like HD Insight over there. Now, the next interesting piece over there is actually facilitating advanced analytics on top of all of this data. And this is great. I got a modern data warehouse. I can tap into structured and unstructured and do magic with my data. My data is all enriched. My data warehouse has a lot of new information. Now I can correlate social trends and weather data with my sales and whatnot. But how do I do some deeper insights in there? Well, those compute engines that are already in place can also enable you to tap into some specialized machine learning and advanced analytics pieces that's sitting on Azure. We talked about this as part of the advanced analytics box on the slides earlier. This is where it sits as part of the architecture as well. You can now go ahead and tap into that compute engine, scalable compute engine, to do some machine learning, potentially even deep learning, And if you listened to some of the keynotes yesterday, you know of the awesome capabilities that we've just announced in the space as well. But the interesting thing is, it's not that you have this, so you should do that. It's actually, you need this compute engine to leverage your machine learning environments better. That machine learning can only be as good as the quality and the quantity of the data that you provided. You provided more data to learn, it'll produce more accurate results. You provided cleansed data, it won't produce garbage values. And for you to be able to do that and work on terabytes, if not petabytes of data, you will need that scale-out compute engine. You cannot scale up on a server to cater to those things. You will need those scale-out engines to tap into, to deploy your models into, such that your models that have been created can now work on humongous amounts of data of whatever structure that's coming through. And the interesting piece, the data lake environments actually provide these machine learning models a capability to tap into some of the native data to derive native capabilities and qualities of it that some of the data orchestration engines may have lost in the process. Now this is great. We've done modern data warehousing. We could tap into doing some advanced analytics on top of it as well. Let's take a look at what Azure Machine Learning is and the announcements from yesterday. So in essence, we always had this whole capability of Azure Machine Learning Studio. Now what we are also enabling is the core data scientists who are very close to their own environments of either R or Python or Jupyter notebooks or doing exploratory analytics, etc. Now they have an environment of their liking to tap into and productionize sophisticated machine learning models from Azure Machine Learning. Now that does not mean that the studio goes away. The studio stays there. That is for the citizen data scientist, and this is for the specialist data scientist. Okay? And you can choose to deploy it. The first example over there is Spark. Well, Spark on HD Insight. You create those models here, you go ahead and do some analysis on top of it, and then you can deploy those models into your big data engines so that it can work on all the data that it already possesses. That's the power of machine learning. Now coming back to our architecture over here, we've done advanced analytics on big data as well. What's really interesting over here is, this is all great till we get to a point where Azure Storage can actually listen to the throughput requirements and the data size limits that you have, etc. Now, there are organizations in the world which are so specialized and do such advanced big data processing that they need even better engines to work on top of. That is where the likes of Azure Data Lake Store and Azure Data Lake Analytics really comes in and shines. You can just replace storage and HD Insight with the Data Lake Store for even better massive scale and analytics specific throughput requirements to your underlying analytics systems. And with Data Lake Analytics, you're bringing in your knowledge on C# and T-SQL to bring it together in a very developer-friendly environment and writing SQL-like queries on top of your big data to structure it and stream it. What's even interesting is SQL allows you to write Python and R models on top of the data as well. In addition to that, you can fire up cognitive capabilities on top of all of your data via SQL. Now that's amazingly powerful. And that is the essence of what big data is going to look like in the future. And if you're on it today, you're actually living it as it grows. But then, just for simplicity's sake and to keep everybody together, let's take a survey of what data lake is. Oops. It's an on-demand analytics job service powering intelligent action across a hyperscale repository for big data analytics workloads. Now, somehow has a timer to it. Sorry about that, but as we get to it, it's essentially an environment where you don't have to manage clusters. It's a serverless querying environment. It's a big data as a service environment. It allows you to tap into knowledge that you already possess and bring that to the fore. It's allowing you to do away with all that administration, monitoring, and all of those capabilities over there. And it allows you to concentrate on your business and the queries that your business has. Now, as we see this slide over here, try to put together how the three kind of big data compute engines that we have on Azure stack up. We didn't talk a lot about the Azure Marketplace or the IaaS clusters, but yeah, I mean, if you have some on-prem environments and you really want to tap into that same bits because you've customized them for your business and to your liking, and you want them up on Azure as well, go ahead, party on. Marketplace, IaaS clusters, do that. But more often than not, and potentially 99% of the times, you would not be affiliated to one particular version of Hadoop or Spark, or you wouldn't have done so many customizations that can't be ported across to HD Insight. Because HD Insight now offers you all the capabilities of the same open source analytics stack without the worry of administration and monitoring. But then you've got big data as a service where you don't even have to worry about clusters. You just bring in your business queries, you tap into your business data residing in your data lake, and you write queries on top of that to curate and process that data. And further on, your data warehouse can tap into your data lake to port that curated data into a presentable manner in the form of a data warehouse. Now, this is all amazing. And just diving a little deeper on how these solutions stack up over here as well. Now, it's not for us to read, but just to grasp that there are reasons why these solutions exist in tandem on Azure. There are capabilities that they project that cater to certain audiences and attract the positioning from that perspective. And when it comes to using the right solution for the job, you even have a proper guidance to tap into. If you need OSS, if you are .NET friendly, do you have streaming requirements or batch requirements? Do you need to tap into a particular type of data? All of that can be taken into consideration over here. Now, coming back to our base architecture, big data, advanced analytics, all of this done over here. This is, again, great. But now I also want to tap into some of my live operational data. I talked about Cosmos DB earlier. Cosmos DB can now come into the picture and show you what the capabilities of tapping into Cosmos DB via Spark connector could be. Just imagine your HD Insight cluster running on Spark, leveraging all the unstructured data residing in your data lake, and then going ahead and tapping into behavioral data as it is getting generated by users in real time. That's your live operational data. It's a kind of concept where now you can go ahead and tap into the insights from machine learning and directly put it into that operational store for your users to get benefit from right then and there. Now, of course, the more the data, the more the context to that data, the better my machine learning insights and advanced analytics is on that data. So here's a quick look at what Cosmos DB looks like. Well, I explained Cosmos DB. It's a globally distributed, massively scalable, and multi-model data service. It offers all of these model types. It offers you very high SLAs and very low latency times to the tune of less than 15 milliseconds per query. And that's bounded by financially backed SLAs. Now that's all great. Let's take a quick look at such a solution in action. Let me quickly tap into my machine here. I'm going to duplicate my screen. Hope all of you can see this. I'm going to tap into my phone over here real quick. We talked about operational data. We talked about the snappiness of the experience as it came through. Let's quickly take a look at one such experience over here. Here, I'm at an app. This app is a retail app from Wide World Importers. It's selling me shoes. Now what's interesting is it's tapping into a lot of data points that were previously not possible if this was just tapping into operational data. It's tapping into trends from social media feeds. It's tapping into nearby events. It's tapping into weather. It's tapping into location and where I reside. And it's giving me a personalized page right up front. Now this is all great. It's trying to reduce that time to purchase that I have. I don't have to go search for things. It's looking into social media and trying to determine what are those products that I was liking or talking about or hovering over a lot. And it's trying to offer me something similar, very cool over here. Now let's tab into one of the street shoes. This is great. Look at this. They even identified my preferences for the colors. They tapped into something like Pinterest, where I pinned something similar on it. And they determined certain attributes with deep learning models to determine that green is potentially my favorite color. And if I have those shoes in green, show that first. Now, $99, $100, probably too much for these pair of shoes. They even observing that and trying to give me some promotional offers in real time. In this case, they're tapping into my distractedness from that price point, and they're offering me a discount on it. And additionally, to their business's benefit, they're tapping into their in-store capabilities or the point of sale systems and determining what the inventory is and whether there is some overage on the inventories and trying to tap that into my promotions. So if I take or choose to pick it up from a nearby store which has a lot of inventory, I get an additional discount because that inventory doesn't need to be sent back to the warehouse anymore. I can go ahead and choose one of those, check it out, even integrate AI into those experiences and tap into going ahead and signing out from that perspective. It gives me a QR code that I can now go ahead and tap into from an in-store perspective, and that now gives the in-store salesperson another touch point to see if there is an upsell opportunity. Let's quickly go ahead and see what the business users look at from this perspective as well. Just going to come back over here, and we'll connect to the marketing manager dashboard. Now here's a dashboard that a marketing manager sees. All of the data is being brought together from the modern data warehouse. He's looking at structured, unstructured data from social sentiment, from geographical locations, and it's tying it back to revenue. What's really interesting over here is the sentiment by product category. Men's clothing is showing a very high positive sentiment denoted by that green bar over there. How does that translate into sales? Can I do something to make sure that the sales for the product are very high? Well, of course, I can launch promotional campaigns. But which campaigns to run? There is so much I can do. What do I do? What is the right level of discount to offer? and what is the ROI that I can get from it? Well, you can actually have machine learning models help you do that. You can go ahead and take a look at recommended campaigns and then tap into some of these recommended campaigns over here, which says, in the first one of which is actually identifying that I need something very similar to 10% off on men's clothing. And if I go ahead and do that, I'm actually able to go ahead and get an 82% ROI on my investment. Now, how do I do that? Well, it's all integrated into my CRM systems, my business systems in the back end. So I can just go ahead and launch this campaign, and it identifies and triggers a workflow within Dynamics to go ahead and do this. Now, this is all interesting, but what's making this possible? Can I look at the back end a little bit? Well, here's the solution architecture for that entire application as we looked into it. What we are looking at is structured and unstructured data coming together in the form of a data lake, in this case, the Azure storage. You're tapping into Spark to be that analytics and intelligence engine in this case. You're tapping into ML libraries in R within Spark to go ahead and give you that capability of determining what campaigns to run, whether there is a risk to customer churn, what to do in real time. All of that data, once curated, is fed into your SQL data warehouse for your BI systems to work on, but at the same time is fed into something like Cosmos DB for your app experiences to get enriched. So the next time the user comes in, they see a more personalized experience for themselves. The next time the user's tapping into one of the products and thinking about its price, you're able to make real-time decisions and offer them promotional discounts, etc. And all of this information is actually coming together with the power of Azure. Just to show you all of these assets, this is the resource group that's making that demo possible right now. All of these assets, the storage account, the Spark cluster, the data warehouse, the Cosmos DB, the SQL DB, the analysis services, the Power BI workspace, even the Visual Studio environments plugged into this whole solution over here as it is. You can tap into any one of them. Let's just go ahead and do this. Like, I want to go ahead and tap into my data warehouse, and I am going to see some seasonality coming through from my data warehouse environment, and I want to go ahead and scale it up. How do I go do that? Well, it's as simple as coming to your data warehouse, hitting on scale, and dragging your scale over here. Similarly, you can actually go ahead and do a bunch of things with HD Insight. You come in here, increase the scale of it, design clusters. You have cluster type. You have cluster types of the following capabilities: Hadoop, HBase, Storm, Spark, R Server, Kafka, interactive query clusters, which just went GA this week with High-Level AP. What's also interesting is Data Lake. How can I forget that environment? Well, in fact, I'd love to show you Data Lake within Visual Studio, let alone Azure. You can come into your Visual Studio environment, write SQL-like queries. Look at these queries. Isn't this something like select star from where group by? That's what you're doing within Data Lake. And now you're tapping into unstructured data. And when you want to go ahead and execute this, well, no clusters. You just come in here and say, execute this query with X amount of parallelism. Microsoft takes care of executing that. At the same time, gives you insights into that. Just to show you one such query that ran, well, here's a job graph of that query. You can dig into it with developer tooling to determine if there are any bottlenecks. You can play it back. A job that may take hours to process, you can play it back to yourself in a span of half a minute or a minute to see if there were any bottlenecks and where you need to dig deeper and parallelize further, and how to optimize your queries so that your systems of intelligence can derive insights faster. That's the power of Azure that it brings to us. And this is not executing the query, mind you. This is just playing back the previous execution of that query so that you can debug and optimize that query even further. Okay? Now let's switch back to the deck over here. Let's get through a few more items. Now, from a demo perspective, we saw like a highly personalized and engaging experience. We saw how business users leverage it. And we saw the solution architecture pieces behind it as well. And it literally translated what we have discussed so far into a solution which is live and running right now. Now, coming back to our architecture, that awesome picture that I just love so much that I can't get enough of it. But then there's one thing missing over here. How do I go ahead and bring in real-time processing? When I get data from sensors and IoT, which is, again, unstructured information, where does that go? Like Data Factory can potentially tap into data sitting somewhere and bring it up. CLI will ask you to give it a source and ingest data. Azure Functions will probably be just sitting idle until a certain amount gets there. How do I make sure that that data is captured as it gets generated, and I get to tap into that data and process that data and derive insights from that data, potentially even do machine learning scoring on top of that data in real time, and derive insights and take actions on the basis of those insights? Well, to enable that, we talked about event ingestion engines. We talked about all of those engines in the first slide. You see all of that coming to life as part of a solution now. Event hubs is that event ingestion environment that allows you to tap into those events as it gets generated, potentially buffer them, and then feed it into a stream processing engine. In this case, I'm just showing that it feeds it into HD Insight, because HD Insight has stream processing capabilities like Spark streaming, like Storm. And now you can score upon that data, process that data in real time, perform windowing operations, aggregate that data, and report it in real time to your dashboard environments like Power BI. Now, this actually warrants a slightly more concentrated look into it. So I've just brought that streaming pipeline down onto a slide and architecture over here. So event hubs into HD Insight, you process it using Spark streaming, you push it back into storage, you even tap into machine learning models to score, you feed it directly into your analytical dashboards, and then via storage into your data warehouse as well. But there were a lot of choices over here as well. Well, first, for ingestion, you can tap into IoT hubs if you need to tap into device registration policies and you want metadata about your devices to be stored and tackled at the ingestion layer itself. But then, if you have some custom operations to perform and you really want to scale out your ingestion engines for millions of events per second, you can actually implement something like Kafka in HD Insight, which allows you to scale as per your requirement and even apply custom logic, which may not be part of, say, Event Hub or IoT Hub. But the choice does not stop at the ingestion piece. The choice is also offered at the processing piece. That's where, again, the ease of use piece really, really shines out. Do you want to go manage your clusters to process streams? Do you want to administer and monitor them day in and day out? Do you want to have a team of administrators sitting and just looking at operational dashboards on the health of the system? Or do you want to leverage easy-to-use SQL-like querying language and tap into these stream processing capabilities of it? Stream analytics really shines over there. Now, bringing it all back together, let's just simplify it and say, okay, HD Insight, that's my batch processing engine, that's my machine learning platform, and potentially that's my stream processing engine as well. And bringing it back together into the Lambda architecture. Now, what's interesting, again, is that the additional platform capabilities don't go away. They still stay, and they allow you to, one, privatize your connections, second, orchestrate this entire pipeline. Are you going to have somebody sitting over there and saying, okay, here, I've got my data, now let's go process this, and then once that processing completes, I'll wait for it, and then I'll go do something else, and then probably go grab a coffee, and by the time I come back, potentially it's moved about 1% higher. Well, you're not going to do that, right? You need automation. You need something to orchestrate that. Data Factory, in addition to allowing you ingestion capabilities, also allows you to have orchestration capabilities so that you can determine what happens when certain events occur and how and which engine to trigger to process the data. You can call HT Insight, Data Lake, Data Warehouse, Machine Learning, Stream Analytics, all of those engines from the Data Factory environment itself. Trying to put together with some of the other choices that we talked about as well. And this is what the slide comes out to be. You ingest, you store it, depending on what kind of analytics you're performing. You then go ahead and consume it using that compute engine. Similarly for stream processing, and then you store it in your data warehouses and report and dashboard upon it. Well, that was a great kind of view of the three solutions and how the services that we discussed in the first slide sit in the form of a data flow diagram for those solutions. But it's also important to understand that it does not only apply to one vertical or one horizontal, it applies across. It applies to manufacturing, to banking, to healthcare, to government, to retail, potentially even more use cases that I may not be aware of today. Just a few examples over here. Tangerine, leveraging that modern data warehouse environment to implement their solutions. Ziosk, I'm sure a lot of us have run into these at the airports. You see those tablets? The next time you see them, just think about HT Insight, just think about Azure, just think about Data Lake. Just think about how your interactions are getting enriched over there and personalized for yourselves. And then there are many more customers who are putting these into action as well. Well, it all comes to life with the capabilities of Azure as a whole, which gives you hybrid and productive and intelligent environments and a trusted kind of compliance. Which leads me to certainly one of the last slides up here, which is about compliance and all the various levels of compliance that we have today. That I actually want to leave you with one video.
The most important thing to our customers is keeping the lights on and saving money.
With a customer like Seattle City Light, part of their business model is changing.
Some of the biggest challenges are just collecting and handling the vast amounts of data.
It's 20 terabytes plus of this raw data coming in, and it's up to us to figure out how they drill down farther. But the thing about AWS is it was pretty expensive, and it was sitting there running all the time. Even when we weren't running queries and using it, it didn't make sense. And then we started seeing more of the Azure technologies that we liked, like blob storage and Data Factory.
What was very attractive about the Azure platform is that it was laid out in front of us. The architecture was easy to understand and, more importantly, easy for us to explain to our customers. Azure's better than AWS because they've thought the solution through.
The extra convenience of having pause and resume and the easy scale up, scale down, that right there is just a pretty big chunk of savings.
SQL Data Warehouse allowed us to switch over to a large distributed database without changing much of our code. We immediately were able to start to use Visual Studio and Management Studio to interact with these databases.
Had we had LoadSeer several years before, it saves us hundreds of hours of labor. This data is helping us identify where projects are actually critically needed. That's pretty significant.
Data does not become decision-making without intelligence in the middle. And that's where really Azure and IAA put themselves together.
With that, I'd love to thank all of you over here for being here for the session. and I hope you enjoyed and learned something new and got a better understanding of the big data space on Azure. Please take an evaluation if you get the time. Here are my credentials if you want to connect. Thank you so much, everyone.